content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. I am thrilled to announce the upcoming episode of Ask the Lady Electrical Inspector podcast, where I will be discussing an important topic, electrical box fill, particularly in using spray foam with junction boxes and enclosures. In this episode, I will talk about spray foam and why it's essential to follow specific rules to ensure electrical safety. This includes understanding the requirements set by the electrical codes and the guidelines provided by manufacturers. I will break down some of the key electrical code requirements that are relevant to our topic, making them easy to understand. I will share real-life examples to show how these rules apply in everyday situations involving spray foam and electrical work. This will help illustrate why following these guidelines is so important. I will also highlight common issues that inspectors find during their inspections, providing tips to help you navigate these National Electrical Code requirements more smoothly. Join me for an engaging conversation aimed at improving electrical installation practices. Stay tuned for valuable tips on ensuring safe and compliant electrical installations. This discussion is all about helping you understand the standards that keep electrical installations safe and reliable. Let's learn together and make sure we are all on the same page when it comes to safety on our electrical projects. Join me, stay informed, and let's keep the conversation going. Let's begin with why it's essential to follow specific rules when spray foaming around electrical junction boxes and enclosures to ensure electrical compliance. This includes understanding the requirements set by the authority having jurisdiction, the national code, and the guidelines provided by the manufacturers. Spray foam installation is a popular choice for keeping buildings warm and dry. It works by creating a barrier against air and moisture, making it ideal for places like roofs, attics, walls, crawl spaces, and basements. The installation comes in two parts that, when mixed together, expands into foam. Professionals take care of mixing this process using special equipment. And when the foam is applied, it starts off as a liquid and quickly expands to fill any cracks and gaps. Electricians know how important it is to keep air from leaking in and out of our homes and businesses through walls, ceilings, and floors, especially in areas that are not heated or cooled. When we seal up these spaces properly, it not only makes our homes more comfortable, but also helps us save on energy bills. Plus, good air sealing can prevent problems like dampness, mold, rust, and damage to wood. To help achieve a tighter seal, architects and builders often recommend specific methods. This includes sealing around electrical outlets. One effective option for insulating our homes and businesses is spray foam. This type of installation does double duty by sealing up air leaks while also providing warmth. When using spray foam around electrical wires, it is crucial to follow safety measures for effective electrical installation. The foam acts as a seal to enhance energy efficiency by preventing air leaks. Although spray foam generally does not conduct electricity, it can retain heat. So caution is advised to prevent overheating, especially with overloaded wires, bundling of NM cables known as Romex or MC cables. The National Electrical Code plays a key role in keeping electrical systems safe. One important part of this code is Article 314, which provides guidelines for how to choose the right size for the electrical box. These boxes are essential for holding wires and connections securely. By following these requirements, we can ensure that everything fits well and works safely. Another important section of the National Electrical Code is Article 110.3a. For electrical installation, 5 heating effects under normal conditions and use of and also under abnormal conditions likely to raise in service. Article 110.3b, installation and use. Listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. Article 110.12b. This part highlights the need to keep electrical equipment in good condition. It's crucial to make sure that the equipment does not have any damaged parts, like those that are broken, bent, or rusty. Damage can pose risk to safety and affect how well the equipment functions. Additionally, it's important to be aware of safety hazards related to materials like spray foam. If spray foam gets into electrical junction boxes, the boxes that keep connections that help connect electrical wires, it can create serious safety issues. These boxes, the junction boxes, are designed to help dissipate heat and protect electrical components from overheating. Therefore, it's vital to keep these boxes clear of any foreign materials to maintain safety standards in electrical installation. In a bit, I will talk about some important rules you need to know when setting up electrical junction boxes near spray foam installation. These requirements help keep everything safe and up to code. I will share with you guidelines from the authority having jurisdiction policy regarding the use of spray foam inside electrical junction boxes and other devices that are enclosed. Electrical equipment approved for use in spray foam installed walls. The purpose, this notice is being sent to all active electrical license holders so that they will know the position of the Office of Electrical Inspections relating to the type of electrical equipment judged suitable for use in spray foam installed walls. Equipment judged suitable will be approved. The reason This notice is the result of inspections where spray foam was found inside device boxes. No attempt was made to protect the device boxes from foam contamination, and in most incidents, the foam was intentionally applied to the exterior of the box, which resulted in additional foam entering the device box through the knockouts in the box. The foam expands, thereby increasing the volume of the foam inside the box. The code violation. Both the National Electrical Code and the authority having jurisdiction prohibits the contamination of electrical equipment with foreign materials. Furthermore, contaminated electrical equipment is required to be replaced. Spray foam installation for the purpose of electrical code. Why is certain electrical equipment required? Cable assemblies, their connectors, and the device boxes used with cable assemblies are not designed to keep a product like spray foam from entering the equipment. Article 300.6 of the National Electrical Code requires electrical equipment to be suitable for the environment in which it is installed. A raceway type wiring method used with listed fittings and used with boxes that have no holes in the back of the side could be judged suitable for the environment, as the foam will have no entry points except the opening for the devices, which must still be protected by the job where the spray paint will be used. Are there other options? One option would be to install the rough wiring after the spray foam installation was applied. The stud spaces are not completely filled with foam. We anticipate that this method would require the electricians to remove some foam where device boxes are located. Holes through framing members shall be located no less than 1 inch from the edge of the framing member. Protection nail plates would be required to protect the wiring. The electrical contractor would need to determine if the after-fact method was a better option than installing a wiring method that is suitable for an environment where a spray foam will be applied after the rough wiring was installed. What wiring methods are approved? Any of the raceways in Chapter 3 of the National Electrical Code would be approved. Obviously, some would be difficult to work with, especially in wood framing member and boxes. Have holes that will need to be sealed by the electrician. The non-metallic raceways would also be approved. Some, like ENT, might be well suited for certain applications. ENT boxes that have no penetration holes are available, or otherwise the electrician would need to seal the holes like any other device box. How does this affect the electrical contractor? The electrical contractor must know when spray foam will be installed on a project. If spray foam will be used, then observe this notice and sealing holes openings. In device boxes, we will be the responsibility of the electrical contractor. This will add to the cost of the electrical installation. The electrical contractor would know best how this will affect the cost of the electrical installation. This notice should only affect the electrical equipment in the interior walls, as those are the only walls usually insulated. The equipment in these exterior walls is just a part of the electrical installation. The rest may be completed using cable assemblies and standard boxes. However, if spray foam is applied in any wall, ceiling, cavities, or hollow spaces for any reason, this notice will apply. Using an approved wiring method will be less costly when removing and replacing contaminated equipment. This notice will change if, when necessary, to reflect new methods or practices, or to add another product if they are found to be contaminated to the electrical equipment. This is a spray foam policy from the authority having jurisdiction. What is the National Electrical Code? The National Electrical Code is an important set of minimum requirements for minimum rules for ensuring safe electrical installation in the United States. It provides guidelines on how to properly set up electrical systems, keeping both homes and businesses safe and running efficiently. The National Electrical Code is updated every 3 years by a group of experts, making sure it stays current with new technologies and improvements in safety standards. One important area the National Electrical Code covers is the installation of junction boxes and enclosures. These are essential for properly securing and managing electrical wiring. A specific rule in the National Electrical Code stresses that all parts of the electrical equipment, such as wiring, connection, installators, shall be protected from damage and shall not encounter harmful substances like paint or cleaners. A key National Electrical Code requirement, as specified in Article 110.12b, Article 300.6, Article 300.16b, in regards to spray foam. Here are some critical code requirements related to this subject. Article 110.12b, integrity of the electrical equipment. Connections, internal parts of the electrical equipment, including bus bars, wiring, terminals, insulator, and other surfaces, shall not be damaged or contaminated by foreign materials. C. Integrity of the electrical equipment and connections shall not be bent or damaged by foreign materials such as paint, plaster, cleaners, or abrasives or corrosive residue. What are the National Electrical Code requirements for junction boxes? Volume, Article 314.16b. Article 314.16 specifies the minimum volume size of junction boxes required for various types of electrical conductors. The volume size of a junction box is measured in cubic inches. It is determined based on the number and size of conductors within the box. You must also consider the volume of the box of the devices and fittings installed within the boxes, such as switches or receptacles. The code specifies the minimum box size you will need for different wire size and the minimum volume size of the box required for a different number of conductors. For example, a box that contains 3 to 6 conductors requires a minimum volume of 18 cubic inches. Accurate calculations rely on knowing what items are being installed and how much space those items will need. Article 314.16b, box fill calculations. 1, B1 through B5, as applicable, shall be added together. No allowances shall be required for small fittings such as lock nuts and bushings, and also wire nuts. These shall not be counted. No allowance means do not count lock nuts or bushings or wire nuts. Some feel that there may be an issue with the spray behind the box in contact with the Romex cable. See NEMA Bulletin 95 for additional information. So table 314.16b, volume allowance required per conductor. I'm not going to do the calculations for you, but the conductor sizes are on the left. The cubic, what you're supposed to calculate with, is on the right. And you use this table to calculate your box fill. I'll leave it there. And you should do this in some type of apprenticeship setting. I just want to let you know what is being counted for the box fill. That with the spray foam, this is why nothing else is allowed inside the box. Table 314.16b provides volume allowance to be used when calculating the number of 18 through 6 conductors permitted in a box. Article 314.16b1 requires each conductor that originates inside the box and terminates or spliced within the box to be counted once, and each conductor passing through the box without splice or termination is also counted once. Using spray foam in electrical junction boxes is not permitted, as it can limit future access to electrical connections and reduce available space within the box, which goes against the requirements outlined in Article 314.16. It's important to ensure proper compliance with these requirements to maintain safety and accessibility in electrical installations. Manufacturer's instructions. One key aspect of the National Electrical Code is the importance of following the manufacturer's instructions. This is closely connected to Article 110.3, which emphasizes that proper installation and operations of electrical equipment must align with the guidelines provided by the manufacturer. In simple terms, to ensure safety and efficiency, it's crucial to use electrical products following the specific directions given by their makers. Article 110.3A, 4, electrical installations. A5, heating effects under normal conditions and use under abnormal conditions. Per manufacturer's instructions. Remember, spray foam is produced by a reactive chemical process. When you apply even in a small quantity of spray foam, be sure to wear protective gloves, glasses, and clothing, and follow the manufacturer's recommendation regarding ventilation or breathing protection to avoid having that chemical reaction occur on your skin or in your lungs. Per manufacturer instructions, Article 110 3B, installation and use, listed and labeled equipment shall be installed and used in accordance with any instructions included in the listing. Per manufacturer instructions, when applying spray foam over electrical wires, ensuring safety is paramount. To begin, it's crucial to verify the compatibility of the chosen spray foam with your home wiring. Here are some key tips for effectively applying spray foam over electrical junction boxes. Reference to local building and electrical codes for precise regulations on foam installation around electrical boxes. Electrical wiring should be done before spray foam installation is applied, and the foam should be installed carefully to avoid obstructing access to the wiring. Consider using conduit raceways for added protection, especially when working with spray foam installation. Cable sheath. Electrical cables are already insulated with their own protective sheath, and adding spray foam can lead to overheating. When applying spray foam around electrical boxes, it is important to do so around the box exterior, not inside. Securely cover all junction boxes with duct tape or some type of tape to prevent foam from infiltrating. Avoid overfilling to prevent undue pressure on the box and internal connections. Leave a small gap for future access or inspections, ensuring continual functionality. Safety should always be a priority when working with spray foam around electrical equipment. Verify the spray foam compatibility with your home or business wiring. Please inspect wires for any damage or overheating. While spray foaming over wires or cables is not recommended, exercise caution at junction boxes for easier future electrical work. Per manufacturer instructions, proper handling of spray foam is essential for safety. Always wear protective gear such as gloves, a mask, and eyewear, and work in well-ventilated areas. Follow manufacturer guidelines for applications, methods, and store foam containers in cool, dry places away from sunlight or heat sources. These precautions ensure professional results and protect against potential hazards. Now, I will share real-life examples to how these rules apply in everyday situations involving spray foam and electrical work. This will help illustrate why following these guidelines is so important. When the inspector visits your construction site or your home, the electrician should have completed the basic rough cover of the electrical wiring before the spray foam installation is applied to the walls and ceilings. However, sometimes it's avoidable to run some electrical wires in the walls that have already been insulated with spray foam. When the insulation is applied, electricians need to be careful to keep the spray foam from getting inside the electrical junction boxes where the wires connect and the other equipment. Covering these junction boxes with duct tape or other equipment method can help keep out the foam. This way, there's less chance of damaging the installation, and it often means that no extra repair work will be needed later. If careful steps are not taken before applying foam installation, you could face problems during your electrical inspection. If the junction boxes or enclosures does not meet the safety standards set by the National Electrical Code, the inspector will not pass your inspection, and you will need to make repairs before moving forward with your construction project. To avoid further issues and reduce repairs, it's a good idea to remove large amounts of foam from inside the junction boxes before the inspection takes place. This can help ensure everything goes smoothly. Now, I will discuss common issues that inspectors find during inspections, providing tips to help you navigate these requirements more smoothly. When adding new electrical wiring or circuits, it's important to protect the junction boxes from the spray foam to avoid unnecessary repairs later. If any damage happens to the electrical connections or the junction boxes, you will need to fix them before continuing with your construction project. I can't stress that enough. Here are some easy tips to follow to help prevent these problems. During the inspections, I often see excess spray foam that has accidentally got into the equipment or the junction boxes. That's what we're talking about. Make sure that the wiring is pulled tight, secured roughly every 2 feet during the initial installation. This keeps it in place, especially since foam expands. When wiring that meets safety standards to avoid complications from using the wrong types. Use special covers for electrical boxes to stop foam from getting inside the back of the boxes. It's a good idea to cover the front of the boxes or the panels to help keep the foam from spilling inside. Remember that while spray foam installation is great at keeping the heat in, it can catch fire. Always follow safety codes and the manufacturer's instructions about keeping heat-producing equipment away from spray foam. Extra foam inside the junction boxes. By sticking to these straightforward tips, you can avoid issues with your electrical inspection. When working around spray foam installation, if you have any questions, reach out to the foam installer for advice on the best products to use for your project. Safety and adherence to guidelines are essential when working with spray foam and electrical components. Following the National Electrical Code guidelines is not just a good idea, it's required by law in many places. This compliance is critical for reducing the chances of electrical fires and other dangers. Ignoring these regulations can lead to serious consequences, like fines or legal issues. Ensuring that electrical work meets National Electrical Code standards is vital for safety and can help prevent dangerous situations. Remember, it's vital to get approval from your local authorities and work with a licensed electrical contractor before starting any electrical work. Staying informed about these safety practices is essential for keeping everyone safe. Let's help spread the word about the importance of electrical safety. Join me on April the 16th for an important discussion about modifying existing electrical switchboards and panel boards. I will explore the challenges and risks that come with these changes and explain why they can conflict with safety rules set by the authority having jurisdiction and the manufacturer. I will provide key advice to help you avoid problems down the road. Let's work together to ensure electrical safety for everyone. Visit my YouTube channel where I post short videos showcasing common mistakes in electrical inspections. You can learn about the best practices to follow and what to avoid when dealing with electrical systems. If you are interested in understanding more about electrical standards, check out the list of 60 Best Electricians Podcasts, podcast.feedspot.com/electrician podcast. Feel free to reach out on social media with any questions, comments, or topic ideas. You can find me on Facebook, Instagram, YouTube under the name Ask the Lady Electrical Inspector. You can email me at asktheladyelectricalinspector@gmail.com for more discussion or to share your thoughts. Let's work together to keep our electrical systems safe and up to code. Thank you for your time and have a great night.